In the previous videos, we have talked about Cauchy sequences. And in this video, we're going to look at one of the basic properties of Cauchy sequences, which is that every Cauchy sequence is bounded. So suppose that you have a Cauchy sequence, P1, P2, P3, etc., in some metric space. The claim is that it's bounded. So recall that to say that a sequence is bounded, so just a reminder. So the thing is that a sequence is not the same as a set of points, right? Because a set of points is just a bunch of points, whereas a sequence, you're saying which point comes first, which point comes second, which point comes third. So there's an ordering of the points. And also a lot of the points could be the same. So for instance, you can have a sequence where all the points are the same. That would be a sequence, but then there's only one point. So a sequence of points is not the same as a set of points. But to say that a sequence of points is bounded, so let's say the sequence is P1, P2, P3, ... To say that this sequence is bounded means that the set of points now I'm using the set notation, P1, P2, P3, etc., is bounded, meaning that it's contained in some open ball. All right, let's go to the proof. So you have a Cauchy sequence, so let P1, P2, P3 be your Cauchy sequence. Well, the idea of a Cauchy sequence is that given any epsilon, eventually all the points are within epsilon of each other, right? They're at most epsilon distance away from each other. And so let's actually look at a specific value of epsilon. Let's take epsilon to be, you can take epsilon to be whatever positive number you want, but let's take epsilon to be 1, because 1 is a simple number. So take epsilon to be 1, then we know that there exists some integer n such that for all m and n greater than n, the distance between p sub m and p sub n is less than epsilon. So basically, when you take epsilon to be 1, eventually all your points in your Cauchy sequence are within 1 away from each other, right? So the idea is look at one of these points. So fix an m greater than n. Say m equals capital N plus 1. So you have this point p sub n plus 1, right? Now, for all little n greater than, so your m is your capital N plus 1. So for all little n greater than capital N, the distance between p sub n plus 1 and p sub little n is less than 1. So that means that p sub n plus 2, p sub n plus 3, etc., all those points for all the points in your after p sub n plus 1, okay, those are all within 1 away of p sub n plus 1. So if you just look at the epsilon ball of radius 1 centered at p sub n plus 1, that contains all the points from the nth plus 1th term onward. So what that means is there can only be, what are the points that could be outside of this ball of radius 1? Well, there can only be finitely many. They can only be the points P1 up to Pn. So Therefore, the only points in the sequence that can be outside, that might not be in the ball of radius 1 centered at p sub n plus 1 are p sub 1, p sub 2, up to p sub n. Because you know that everything else is contained in this epsilon ball. Okay? Now it's possible that some of these pi's from 1 to n are also in this epsilon ball, but they're not required to be in the definition. So you could have p sub 1 here, p sub 2 here, p sub 3 here, up to, p sub n, say, out there. But it's a finite number. That's the point. All but finitely many of the points are in this ball of radius 1. So what that means is, okay, so we're trying to show that this Cauchy sequence is bounded, that the set of points is bounded. Well, let's try to take a ball centered at p sub n plus 1. So we know that if you take a ball of radius 1, it contains all but finitely many. So what's left is these finitely many distances, like the distance from p1 to p sub n plus 1, the distance from p2 to p sub n plus 1, distance from p3 to p sub n plus 1, and there's a finite number. So what radius should we take? What radius should we take for the ball centered at p sub n plus 1 that will contain all the points in your Cauchy sequence? I think we should take the maximum of these radii, right? The maximum of these distances. So this length here is the distance from P2 to P sub n plus 1. This distance from here to here is the distance between P sub 1 and P sub n plus 1. And so if you just take any r that's just greater than all of these distances and take the epsilon ball centered at p sub n plus 1, that's going to contain all the points in your sequence. And that will prove that the Cauchy sequence is bounded. So, okay, so therefore, let R be anything greater than the maximum of, well, 1. So you have 1 because of this ball of radius 1 centered at p sub n plus 1, and then the distance between p sub 1 and p sub n plus 1, the distance between p sub 2 and p sub n plus 1, all the way to the distance between p sub n and p sub n plus 1. Then the distance, then for all n, the distance between p sub n plus 1 and p sub n is less than r, right? Because this r is greater than the distance between p sub n plus 1 and pi from I equals 1 to n. And then for all the other points, those are contained in the ball of radius 1 centered at p sub n plus 1. So therefore, the entire sequence, the set of points I mean, okay, this set of points in your Cauchy sequence is contained in the ball of radius r centered at p sub n plus 1, and so the Cauchy sequence is bounded. And that's the proof. So let's review. This is an important, well, it's a useful proof to remember. This fact is sometimes useful. It's helpful to get intuition for Cauchy sequences and to know that you can't have something like some unbounded sequence. So you can't have like 1, 2, 3, 4, 5, etc. That's not going to be a Cauchy sequence because it's not bounded. So the idea is you just fix any epsilon greater than 0. In the proof, I took epsilon to be 1, but you didn't have to. So let's just make a note. Any epsilon greater than 0 will work. You could take epsilon to be 1 over a million. That's fine, because in the definition of Cauchy sequence, no matter what your epsilon is, there is some integer capital N such that for all little m and little n greater than capital N, the distance is less than epsilon. The distance between p sub m and p sub n is less than epsilon. So what that means is that once you take a specific little m, okay, and then look at the epsilon ball centered at that point, that's going to contain all the terms in your sequence after p sub capital N. So then you have only finitely many points left, and then since you have a finite number, you just take the distances, and then you can take the maximum, right? Because you can take the maximum of a finite number, and that is the radius you take. So you take the ball centered at p sub n plus 1 of radius r, and then that contains the entire set of points in the sequence. And also note that so here I took little m to be capital N plus 1, but any number greater than capital N will work. So you could take 2n, you could take 3n, you could take whatever, right? And the proof will still work. Okay, so that's the proof that every Cauchy sequence is bounded.